All right, so this is part 2 of 6-8. I'm just going to go ahead and jump into the problems that we have here. So number 6 wants us to make a scatter plot, and we're going to compare the table that we got in question 3 to the scatter plot that we got in question 1. So I'm going to use some different colors here. What we're going to do here is compare how adding $50 a month affects the savings. So is it going to change a lot? Is it going to change a little? So we'll find out there. So I'm going to do different colors here. So with blue is going to be our explicit rule that we found in question 1. So that function in question 1 that we had was t equals 200 times the interest of 1.1 times n. And then we're going to compare that to what we have in question 3, or that table that we had. So we didn't come up with an explicit rule. We said we couldn't do that because our what he was earning each month kept changing, so we couldn't have something that is as basic as an explicit rule. So we start at t equals 200, and then that was times our interest right here, and then plus the $50. So we have to make a scatter plot out of this. So I'm just going to go ahead, let's go and label our axes and give this graph a title. So our independent variable, or x, is going to be the months. So it's going to be time. So we're going to have 0 down here, 1, 2, 3, 4, 5, 6. We're only going to go to 6 because if you remember, or if you look at the table that we did in question 3, they only went to 6 months. That's going to be enough time for us to see the difference between the two. So we'll just cap it right there. And then our y-axis is going to be, of course, his savings. Put a dollar bill there. So we're going to go by 100 here. So here's 100, 200, 300, 400, 5, 6, and then 7 right here. We can have them running into each other. Of course, we need a title. We can make this as complicated or creative or as simple as we want. That's the easiest way to name it right there. So this is going to be Derek's savings. All right, so after we make our scatter plot, we're going to need to come up with some coordinates to plot on here. So to get our blue, easiest way to do it, plug that into either Desmos, calculator you have on your own, and then just look at the table. So that's the easiest way to get that one. And then, of course, with our table that we just did, all we have to do is just transfer that over. So I'm going to go ahead and do that right now. All right, so here's going to be our coordinates or our tables through 6 months on each of these. So we're going to go ahead and plot each of these. So I'm going to start with our blue right here. So this is just, he has that $200 and he's getting interest, not adding anything else to it. So he's going to be at 200 after just starting out. After a month, he gets $20 added onto it. He gets a little more added onto it after the second month. Third month, gets a little more added onto it, and so on. So we can see that this function here isn't really increasing all that much. I mean, it's a little at a time. We're only adding that 10%, nothing else added onto it. So we're about right there after 6 months with our blue function. I'm not going to draw a line through these just because I think we'll go over the dots that I put, but that's what we're going to look like with our blue function. So let's move on to our question 3, that table. So it's really the same thing as the blue, except each month he's adding $50 to it. So we're still going to start out in the same place right there. Now after 1 month, we're already at 270. And just adding that $50 is more than he'll make after 3 without adding it. So we can already see that this is going to escalate and increase a lot more. So after 3 months, we're over here. 4 months, we're at 524. After 5 months, we're at 627. Getting that lined up right here. And then finally, after the 6 months, right there, pretty close to the top. So the question's asking, wants to know how that changes the way his money grows. Well, it really doesn't take a rocket scientist to see the amount of increase just adding that $50 does. So if we don't add $50 to it, it's a gradual increase But adding $50 and getting that interest compounded onto it after each month increases it a lot more. And if these functions were to continue to go out, the difference between each month is going to increase. After 6 months, so between these two right here, that's almost $400 difference between the two of them. So pretty easy question to answer here. So adding $50 a month increases his savings a lot. You don't have to put any fancy words on there. I think that accomplishes everything there. So adding that $50, it increases a lot, and we see that there. So let's go ahead and look at number 7. All right, so number 7 wants to know how long it will take Derek to save $2,000 for a down payment if he continues to add that $50 every month, and wants us to explain how we arrived at our answer. So this is the function that we had where we had a t, not a d. So we start at 200, t of n plus 1 equals tn times our interest and plus that $50. So the way that we found it on that chart was, or on that table in question 3, was continually adding whatever that number is, multiplying that times 1.1, and then adding $50 to it. So after 6 months, we figured out that he would be right here. So to get that 7, all you have to do is take this function here, multiply that times 1.1 plus 50, and when we do that, we're going to get $864.10. So we're just going to keep doing that, and our goal is to get a number that's going to be at about $2,000. So you can pause and try to figure out how many months that's going to be. I'm going to go ahead and put the answer on the screen. Okay, so in this case, rounding up or down to this nearest cent isn't really going to affect your final answer here. But if we keep going all the way through, we're going to see that after 14 months, we're going to get $2,156.25. So that's going to be at least that $2,000. So 14 months here is going to be your final answer. So all we did was just take the number before, we just multiplied that times 1.1 and added 50 and got the number after that, and continually did that, and we arrived at 14 as our final answer. So last part of this that I want you to do, I want you to work number 8. So I want to see your work on that. Take a picture, submit it through Canvas at the turn-in. Kind of to set up number 8. So the only difference between number 8 and the problems that we've been working is that instead of $50 he's adding each month, he's adding $100, and he wants to see how this will affect the time that it gets him to save $2,000. So I'm just going to make a small change to our recursive rule. We're still starting at that $200, but this time when we set up our function, we're still going to be multiplied by that same interest, but instead of $50 we're adding a month, we're adding $100. So after 1 month, or after 0 months, he still has that $200. After a month, we're going to go 200 times 1.1 plus 100. So to help you get started there, that's going to be 320. When we get to that second month, we're going to take that 320, plug it back into this function part right here, multiply that times 1.1, add 100 to it, and then you'll get 452. So I want you to keep doing this, and I want you to answer this, how many months it's going to take. You don't necessarily have to explain your answer, just showing your works can be good enough for me. So that is going to be all of this section right here, and then from here on we're going to move on to section 7. Just remember to do number 8 right here. Let me see your work, submit it through Canvas, and then you'll be good for the day.